Okay, Lecture 9, Part 2. So the two rules we're introduced to in Unit 9, conditional proof and indirect proof. These are the forms of the two rules. Let's start with conditional proof. Okay, conditional proof is a rule which allows you to derive conditionals, or allows you to infer at the end of the proof a conditional. So what I'm stressing there is something I'll say many, many times, but it's the most important thing you need to grasp in grasping what conditional proof is and how to use it, right? It's when should I use conditional proof? You should use it when you need to derive a conditional, right? Do not make the mistake of thinking that you should use conditional proof because you see a conditional amongst your premises. If you are given a set of premises, right, and amongst those premises is one or more conditionals, do not make the mistake of thinking, oh, I have some conditionals given to me as premises, maybe I want to use conditional proof. That's a silly thought. You don't want to have that thought because you are given those conditionals. What's conditional proof useful for? For deriving conditionals. So you use it when you need to get a conditional. Okay, the most basic use, the paradigm use of conditional proof is when your conclusion is in the form of conditionals. So as you'll know, if you have read Unit 9, as you should have, this unit stresses a lot the value, the use of working backwards, right? The mantra I've been hammering away at in lectures. Remain conclusion driven. How do you approach doing proofs? You look at your conclusion, you look at the structure of your conclusion, and let the structure of your conclusion lead you to the thoughts about what rules you're going to use to get to that conclusion and what formulas you need to derive, what formulas you need to apply that rule to get your conclusion. That's essential for using these rules involving assumptions properly, right? You look at your conclusion, so the paradigm or basic use for conditional proof is when you see that your conclusion is in the form of a conditional, then you say, I need to derive a conditional. This is an appropriate time for me to use the rule of conditional proof, right? Because what does the rule say? What does it allow you to do? Okay, so this is the form of it, and you'll notice this is the main line, right? So if you have premises, which you will for every proof except for theorems, which are introduced in section 5, I think it is, at the end of this chapter, and you will, I'll say now, you will need to prove a theorem in your second exam, so you need to know how to do theorems, but we'll get to that later. Unless the proof is a theorem is a formula that can be proved with no premises, so unless it's a theorem, every proof will have premises, right? So usually the premises, you see here you've got a main line, so you'll have 1, 2, 3 on the main line. Whatever these premises are, will go here on this main line. Both of these proofs requiring the use of assumptions, or both of these proofs that use assumptions, set their assumptions in, right? Indent from the main line their assumptions. So that's what you have here, this arrow here, and it ends here. It's at this stage that we discharge the assumption, and we put the conclusion on the main line. Similarly for indirect proof, we're going to make an assumption here. This is all the formulas that appear here or inside here are within the scope of the assumption. They're not on the main line. And then when you get to the end of the proof, the conclusion of these rules, conclusion of indirect proof, conclusion of conditional proof, they do go on the main line, right? The same line that the premises appear on. Okay, I'll say more about that in a minute. But this is this is the form for conditional proof. You need to derive a conditional, right? You looked at your conclusion in the paradigm case. You see that it is a conditional. You think, okay, I need to derive a conditional. That is the appropriate time to use conditional proof. So I'll set up for conditional proof. And the rule just says, you're entitled to infer a conditional if you assume the antecedent, right? The form here is P hook Q, so assume the antecedent P, and if through an application of the rules, the normal rules, replacement rules, rules of inference, you can derive the consequent of the conditional, in this case Q, then you're entitled to infer P hook Q, right? It's a very, very intuitive rule, right? It's pretty obvious, right? You want to prove if P, then Q. So what do? You're allowed to, what does the rule allow you to do? The rule allows you to say, let me assume P. Let me prove that Q follows from P, right? I'm inferring Q from P. If I can do that, right? If I can bust out a series of justified steps from P to Q, I'm allowed to infer P hook Q at the end of this subproof, right? And my justification, like my egg chalk, my justification for this rule is, it goes here, but I have left myself enough space. Conditional proof, and let's say this is step, imagine this is step 4, right? That means you had 3 premises, and you had to do a bunch of, say you took 5, 6, 7, 3 more formulas in between P and Q, right, to derive, to finally get to deriving Q. Then the justification that goes here on step 9 is conditional proof, steps 4 through, it says 8, steps 4 through 8, right? That's conditional proof, right? That's it. If you, right, you have a conditional you need to prove, you just assume the antecedent, and making that assumption is, right, indenting here, right, or setting up for a subproof, right? I'm assuming P, I go ahead, I derive Q, and now on my main line, outside the subproof, this is the step where you discharge the assumption, right? Outside the subproof, you're allowed to infer on the main line P hook Q. Okay, now let me say a bit about the different lines. Okay, what is a proof? You're given a series of premises. So for the purpose of the proof, you are given them as if they are true, and you are asked to derive the conclusion from those premises, right? Given that these premises are true, can I show that, in this case, this conditional is true? I haven't got any premises here, you're just imagining that there are premises here, right? Now, in doing a proof, you have to show that the conclusion does in fact follow from only the premises, right? So you're not allowed to say just make assumptions and keep those assumptions, right? If I say to you, prove that B follows from A, right? And you say, well, if I assume C, I can show that B follows. I would say, no, you haven't completed the task. You haven't done what you're supposed to do. You have to prove that the conclusion actually follows, as it were, absolutely, or given only the premises as true, right? Which means you are allowed to make assumptions. That's what these rules are, conditional proof and direct proof. They are involved making assumptions, but you can't you can't finish a proof that has the conclusion you're asked to derive within a subproof, right? First rule, there are 3 rules for guiding the use of assumptions, and the first one is every assumption you make has to be discharged, okay? So what's indicated by the fact that this is that there is a main line, and there are formulas on the main line, right? Premises, and here conclusion, and then there's a subproof, and there are formulas that will appear on this indented line. The difference is, within the context of the proof, everything that appears on the main line is, as it were, absolutely true, or true given the conditions of this proof, right? So what also comes on this main line, on the same line as the premises appear, is absolutely true given the premises are true, right? Whereas what the formulas which are derived within the subproof are only true on the assumption that what you've assumed is true, right? So just look at the formulas you have here. Assuming P, you've derived Q. Are you entitled to say that Q is absolutely true? No, that would be like saying, like I said before, if I say prove B from A and you assumed C and prove B, right? You wouldn't prove the right thing. So you're assuming P, you're deriving Q, but all you've proved is that assuming P is true, Q is also true. But the formula you derive now, that you infer applying conditional proof, or discharging the assumption and doing the last step of your conditional proof, is a formula that is absolutely true. It's as true as the premises. You've shown that if P is true, then Q is true, right? It's sort of the very structure of this subproof is in the conclusion. I assume P, I derived Q. I showed that Q follows on the assumption of P. Right, so P hook Q is absolutely true. If P, then Q is absolutely true. So it's on the main line, okay? So that's the difference between things which are on this indented line and things that are on the main line. Everything on the main line is true given only the premises, or assuming only the premises are true, which, for the context of your proof, you're allowed to assume that the premises are true. Whereas what follows within the subproof is only true on the assumption that what you've assumed is true at the beginning, with the first step of the subproof, that is the making of the assumption. Okay? End of section 2.